The majority of airlines use a form of computerized flight planning, which gives the crews up-to-date information regarding the route. This information includes meteorological data, waypoints, planned fuel, radio frequencies, and much more. To achieve this, the computers are programmed with the operator's aircraft type, aircraft limitations, preferred routes, SIDS and stars, etc. Before each flight, the computer is fed information on wind, temperature, destination, and any other information pertinent to the flight, and a flight plan is produced. In the next scene, we shall look at an example of a computerized flight plan. A typical computer-generated flight plan is shown on the screen. This is a plan for a flight from Gatwick, EGKK, to Frankfurt, EDDF. In a previous lesson on fuel planning, we saw how the fuel load and consumption figures were displayed. We shall now put it all in context by going through each line. Line 1 shows that this is a flight from Gatwick to Frankfurt. The aircraft is a 757 cruising at Mach 0.8. It is an IFR flight on 30 September 92. Line 2 shows that this is a non-stop flight. Departure time is 18:30, and the figures are based on the meteorological forecast given at midnight on the 30th. PROGS is an abbreviation for prognostication, and the fuel quantities are given in kilograms. Although they do not have the same horizontal spacing, line 3 shows the sequence for the figures in lines 4 to 10. We can show this by reading the figures across line 4. In line 4, we read the point of arrival, POA, is Echo Delta Delta Foxtrot, Frankfurt. The trip fuel is 3,091 kilograms. Flight time 55 minutes. Route distance 362 nautical miles. And the estimated time of arrival is 19:25 Zulu. The weight of the aircraft at takeoff is 77,390 kilograms. The landing weight, which is takeoff weight minus trip fuel, is 74,299 kilograms. The available payload is 12,500 kilograms, and the operational weight of the aircraft, 58,638 kilograms. The significance of these last two figures will be the subject of a later lesson. The fuel figures in lines 4 to 10 have been covered in a previous lesson and need no further explanation. Line 5 shows that the wind component used to plan a diversion to Echo Delta Delta Lima is minus 15 knots. That is a headwind component of 15 knots. Line 11 is the route summary, including the standard instrument departure, Dover 6M, and the standard arrival route, Nattenheim 1A. Line 12 shows that the average wind component for the route is plus 29 knots, which is a tailwind component of 29 knots. The maximum wind shear is 5 knots per 1,000 feet overhead the Kilo Oscar Kilo VOR. The average temperature is ISA +1, and the total nautical air miles is 337. The level 370, shown in line 13, is the preferred flight level for the cruise. Lines 14 to 16 compare the fuel consumption and route times for flight levels 370, 330, and 410, and line 17, the airfield elevation of Gatwick of 202 feet. Lines 18 and 19 give the headings for data in rows 20 to 41. And, like row 3, they give the sequence, although the spacing does not match. Rows 20 to 41 break down the route into sections at specific waypoints. At each of these route waypoints, the pilots can check their planning data against the real-time data and confirm things such as estimated time of arrival, fuel remaining, ground speed, and so on. Carrying out these checks ensures the pilots are constantly aware of the flight planning data, and any changes can be easily picked up and resolved. The headings are as follows: Airway designator and minimum sector altitude, waypoint identifier and its frequency, magnetic track, drift, zone or sector distance, zone or sector time, ETA, ATA, accumulative flight time, wind velocity, wind component, ground speed, distance remaining, fuel remaining in hundreds of kilograms, minimum safe altitude, frequency, no change on this leg. Line 42 shows the elevation of Frankfurt is 364 feet. Lines 43 to 46 give the geographical positions of the waypoints, which can be entered by the crew into the FMS. Line 47 shows the total elapsed time from takeoff to the FIR boundaries. The last rows, 48 to 56, are a computerized version of the ATS flight plan. The flight plan we have just been through in detail may not be exactly in the format used by all operators. However, the content will be similar. The use of computerized flight plans eases the workload on the operations department and provides a useful tool for the crew to monitor the progress of the flight.